Okay. Okay. Welcome to the Excel for Statistics course. By the end of the course, you will be able to perform basic business statistics analysis using Microsoft Excel. Then, through this course, you will also learn some of the benefits of using Microsoft Excel for daily needs, which will help you to be able to perform better at your job and your business. Okay, let me share the course material for you first. Okay, so in this meeting, we will learn about the Excel statistical functions. And then the functions that we will learn for now are the Pearson function, the RSQ function, the P function, the Poisson distribution function, and then the prop function, the skew function, and then the skew P function, and then the standardized function, and then for T distribution, 2T functions, and then T distribution function, and then T inverse 2T function, and then the T inverse function. Okay, so all of this is the distribution and the test of probability function. Okay, let's go to the first function. Okay, the first function that we will learn for now is the Pearson function. Okay, Pearson function is a function used to return the Pearson product moment correlation coefficient, R, a dimensionless index that ranges from -1 to 1 inclusive and reflects the extent of a linear relationship between two data. Okay, so the Pearson function is a function used to return the Pearson product moment correlation coefficient, which is R, a dimensionless index that ranges from -1.0 to 1.0 inclusive and reflects the extent of a linear relationship between two data. The syntax of the function is equal Pearson, open the bracket, array1, array2, close the bracket. Array1 is a set of independent values which is required. Array2 is a set of dependent values. It is required to. And then for the example, we have first day and second day data. You can type this data set first. You can pause the video. And after you finish the data set, you can play the video again. Okay, so I hope you already finished your data set. So for the first day, we have 10, 8, 10, 8, 6, 4, and 2. And then for the second day, we have 9, 7, 2, 4, 2. Okay, let's do the Pearson function. Equal Pearson, open the bracket, array1, and put the array2 in here. And the result is 0.89304424. Okay, so this is the Pearson function from this data set. Okay, from the first day and then the second day data set. So this is the Pearson function. And then Next is RSQ, which is the return square function. Is a function used to return the square of the Pearson product moment correlation coefficient through data point is known underscore y and known underscore x. Okay, once again, a function used to return the square of the Pearson product moment correlation coefficient through data points in known y's and known x. The syntax of the function is equal return square, open the bracket, known y's and known x, close the bracket. Known y is an array of or range of data points which is required, and then the known x is an array or range of data points which is required too. So for the example, we have the known y's dataset and then known x dataset. Okay, and then for the you can type this dataset first in your Microsoft Excel. You can pause the video, and after you finish it, you can play this video again. Okay, so I hope you already finished your dataset. Let's do the return square function. Okay, open the bracket. Okay, array of known y's and array of x's. And the result is 0.744845. Okay, so this is the result of return square function from this data set. Okay, so let's go to the next function. Okay, we have P function. Okay, P function is a function used to return the value of the density function for a standard normal distribution. Okay, it's a function used to return the value of the density function for a standard normal distribution. The syntax of the function is equal P, open the bracket, x, close the bracket. X is the number for which you want the density of the standard normal distribution, and it is required. So for the example, we have for the argument we have x in here, and for the data we have 0.5 in here. So let's do the P function. Equal P, open the bracket, put the x in here, and then result is 0.3520653. So this is the result of the P function for 0.5. How about we change the 0.5 into 2.5? The result is 0.017528 So this is the result of the P function for the 2.5. Okay, so this is the P function. A function used to return the value of the density function for a standard normal distribution. And then the next one is a Poisson distribution function. Okay, so a Poisson distribution is a function used to return the Poisson distribution. A function used to return the Poisson distribution. The syntax of the function is equal Poisson distributions, open the bracket, x, mean, cumulative, close the bracket. X is the number of events it is required. Mean is the expected numeric value it is required too. And then the cumulative is, is a logical value that determines the form of the probability distribution returned. If cumulative is true, Poisson distributions returns the cumulative Poisson probability that the number of random events occurring will be between 0 and x inclusive. If false, it returns the Poisson probability mass function that the number of events occurring will be exactly x. Okay, so we have this data set. For the example, you can type this data set first into your Excel, and then you can pause the video. After that, you can play this video again. Okay, so I hope you already finished your data set. So we have 3 for the x, 6 for the mean, and 2 for the cumulative. So let's do the Poisson distribution. Okay, put the x on here, put the mean, and put true. And then the result is 0.151020388. So this is the result of Poisson distribution for this data set. Okay, so you already learned about the Poisson distribution. Then we will move to the next function, which is probability function. Probability function or prop function is a function used to return the probability that values in a range are between two limits. A function used to return the probability that values in a range that are between two limits. The syntax of the function is equal prop, open the bracket, x range, prop range, lower limit, upper limit, close the bracket. Okay, so for the x range is the range of the numeric values of x with which there are associated probabilities, which is required. Prop range is a set of probabilities associated with values in x range. Lower limit is the lower bound on the value for which you want a probability. It is optional. Upper limits, it is the optional upper bound on the value for which you want a probability. It is optional too. So for the x range, we have 0, 1, 2, 3. For the prop range, we have 0.2, 0.3, 0.1, 0.4. And then the lower limit we have 1, and then the upper limit we have 3. Okay, let's do the probability function. Equal prop, put the x range in here, put the prop range in here, the lower limit, and last one, put the upper limit. And then the result is 0.8. So the probability function result for this data set is 0.8. So this is the probability function. And then we have skew function. Okay, skew or skewness. Okay, sorry. Okay, so skew function is a function used to return the skewness of a distribution. A function used to returns the skewness of a distribution. The syntax of the function is equal skew number 1, open the bracket, number 1, number 2, and so on, close the bracket. Number 1, number 2, and so on is the number 1 is required. Subsequent number are optional. Number 1, number 2, and so on is 1 to 255 arguments for which you want to calculate the skewness. So we have this data set 2, 3, 4, 4, 6, 4, 3, 5. Okay, you can type this data set first into your Microsoft Excel. You can pause the video, and after you finish your data set, you can play this video again. Okay, let's do the skew function. Skew, the range and value. The result of the skew function for this data set is 0.30431 9004. So this is the skew function result from this dataset. And then the next one is skew P function, or skewness population. Is a function used to return the skewness of a distribution based on a population, which is a characterization of the degree of asymmetry of a distribution. Okay, so skewness population is a function used to return the skewness of a distribution based on a population. This is a characterization of the degree of asymmetry of a distribution. The syntax of the function is equal skew P, open the bracket, number 1, number 2, and so on. Number 1, number 2, and so on. So for the number 1 is required, the subsequent number are optional. Number 1, number 2, and so on are 1 to 254 numbers or names, arrays, or reference that contains number for which you want the population skewness. So we have this kind of data set. So we have 2, 3, 4, 4, 6, 4, 3, 5. And let's do the skewness population function for this data set. So the result is 0.243998025. So the skewness population function result for this data set is 0.243998025. And then the next function is the standardized function. Standardized function is a function used to return a normalized value from a distribution characterized by mean and standard deviation. The syntax of the function is equal standardized, open the bracket, x mean standard deviation, close the bracket. X is the value you want to normalize. Mean is the arithmetic mean of the distribution. Standard deviation is the standard deviation of the distribution. And then for the example, we have this kind of data set. You can put this data set into your Microsoft Excel first. You can pause the video, and after you finish the data set, you can play the video again. Okay, so I hope you already finished your data set. So let's do the standardized function from this data set. So we put the standardized, put the x, put the mean, and put the standard deviation. And then the result is 1.333333 for, this is the result of the standardized function from this data set. Okay, move to the next function, which is the t distribution to t function. It's a function used in the hypothesis testing of small sample data sets. A function used in the hypothesis testing of small sample data sets. The syntax of the function is equal t distribution to t, open the bracket, x degree of freedom, close the bracket. X is the numeric value at which to evaluate the distribution. Degree of freedom is an integer indicating the number of degrees of freedom. Okay, so we have 1.3 for the x and 30 for degree of freedom. So let's do the t distribution. Okay, we put the x and we put the 30 in here. So the result is 0.20350096. So this is the result of the distribution to t function from this data set. Okay, so the next one is t distribution. It's a function used to return the student's left-tailed t distribution. The syntax of the function is equal t distribution, open the bracket, x degree of freedom and cumulative, and close the bracket. X is the numeric value at which to evaluate the distribution. Degree of freedom is an integer indicating the number of degree of freedom. And then cumulative is a logical value that determines the form of the function. If cumulative is true, the distribution returns the cumulative distribution functions. If false, it returns the probability density function. And then for the x, we have 8 in here. For degree of freedom, we have 3 in here. And then for the cumulative, we have 2. So let's do the distribution function. We put 8 in here, 3 in here, and 2. The result is 0.99799617. And then for the t inverse 2t is a function used to return the two-tailed inverse of the student's t distribution. The syntax of the function is equal t inverse 2t, open the bracket, probability, degree of freedom, close the bracket. So for the probability is the probability associated with the student's t distribution. For degree of freedom is the number of degree of freedom with which to characterize the distribution. So we have 3.35 for the probability and 30 for degree of freedom. So let's do the t inverse 2t function. So we put the probability and degree of freedom, and voila. The result is 0.9494066. So this is the result of t inverse 2t function from this dataset. Okay, so the last one is t inverse function. So t inverse is a function used to return the left-tailed inverse of the student's t distribution. The syntax of the function is equal t inverse probability degree of freedom plus the bracket. Probability is the probability associated with the student's t distribution. Degree of freedom is the number of degree of freedom with which to characterize the distribution. And then we have this data set. So for the probability, we have 0.65, and degree of freedom, we have 3. So let's do the inverse function. Put it in here and put the degree of freedom in here. And the result is 0.42420.162. So this is the t inverse function from this data set. Okay, so I think that's all for now. I hope you learned a lot that will help you in the study. So that's it. And then see you in the next meeting. Goodbye.